Hey, Algebra kids, this is the last section of chapter 7. I can't believe it. Um, Hopefully you had a great Easter break and hopefully you watched the review video before this. If not, stop this video, go to my 7.5 review video. At this point in the chapter, you should have a pretty good handle on factoring. What I'm going to do today is throw a bunch of different types of problems your way, and then you have to decide the appropriate way to factor. Okay, there's going to be some where you are factoring just using GCF, some just using special cases, some just using flowy, and then there's going to be some where you have to combine your knowledge. So we're going to go, I'm going to skip this slide and go to kind of a little flow chart here. So I do want you to write this down in your notes. And this is what I was talking about. We're going to have a couple different steps to follow or questions to ask yourself when you're factoring polynomials. Okay, these are the steps that you follow. And step 1 is always to check for the greatest common factor, or the GCF. That is the very first thing you always do before you start factoring. Even if it's a trinomial, you want to look for a GCF real quick just to see if you can kind of, quote, simplify the problem. Okay, so always look for GCF. There may not always be a GCF, but always look for it. Okay, after you have that, look and see in step 2, it's telling us to look about how many terms do you have. Do you have 2 terms? Do you have 3 terms? If you have 2 terms, always look for the possibility of being dots. And if you have 3 terms, always look for a possibility of a perfect square trinomial. That's why last section is so important, because if you can spot those, it saves you a ton of time with guess and check. One thing your book does not have in this section here, excuse me, step 1, when you're looking at the GCF, or even if you skip GCF and you notice that there's 4 terms, always look to see if you can do factor by grouping. Okay, that's another one. Step 3, if you don't see a pattern of a special case like dots or pst, you want to factor with guess and check. That's what step 3 is basically telling us. They're telling us to do, flowy, guess and check. And then step 4 is it's like checking your work, checking to make sure you have simplified and factors as much as you can without having common factors. Okay, so make sure you jot that down in your notes, all those steps, because that's the process you're going to follow. So let's take a look at the first example. We want to factor 10x squared plus 48x plus 32. I am hoping something jumps out at you. These are pretty big numbers, right, compared to what we're used to seeing with factoring trinomials. So hopefully you notice that there's an actual GCF. So the GCF of 10, 48, and 32 is 2. So the first thing we're going to do is factor out that GCF. When we factor out that GCF, then we're dividing all 3 of these terms by that 2, and we end up with 5x squared plus 24x plus 16. Okay, at this point, this 2 is kind of, you can think of it as a constant. We're just going to drop it down to our next line. But what you want to do at this point is say, do I have a perfect square trinomial? This is a perfect square, the 16, but 5x is not. 5x squared is not a perfect square. So we have to use flowy, or guess and check. Okay, so when we do that, and again, we kind of skip through this because we assume you know it, you factor and you get 5x plus 4 times x plus 4. So if you're factoring out this stuff in parentheses, you end up with 5x plus 4 times x plus 4. Okay, now at this point you want to check your work and make sure you don't have any common factors in there or anything else to simplify. It doesn't look like you do. What you would do is factor out, you do FOIL to check your work, and then when you get that answer, multiply it by 2. So when you're factoring or doing FOIL, this is what you get. Multiply it by 2, and you end up with your original answer. This, guys, you can do like in your, I don't want to say in your head, but you don't have to necessarily write those out. Check the back of the book if you want, but this is how you were to check if you needed to. Okay, let's take a look at this one. We have 8x to the 6th y squared minus 18x squared y squared. Hopefully, again, something's jumping out at you. That looks a lot more than what we're normally used to. 8 and 18 have a GCF of 2. There's also x's and y's in both terms. So we can actually factor out a GCF of 2. Okay, so the GCF of 8 and 18 is 2. X to the 6th and x squared, the largest number or the smallest number of x's we have is x squared, so that's your GCF. And then a y squared also gets pulled out of there. Okay, so our GCF is 2x squared y squared. That's what this is right here. When we divide these terms by that GCF, we end up with 4x to the 4th minus 9. Okay, so now you want to look at what's left in parentheses, and I notice there's 2 terms. There's a minus sign, so it's a difference of 2 terms, but are these perfect squares? And they are. 4x to the 4th and 9, those are both perfect squares, so we can actually do dots with that. Okay, what we're going to do is drop down our GCF. That goes on our next line, and then we're going to factor this using dots. So the square root of 4x to the 4th is 2x squared, and the square root of 9 is 3. So keep that in mind. And it says right here as well if you want to look at it. So our factored answer is 2x squared y squared times the quantity of 2x squared minus 3, 2x squared plus 3. Okay? The plus and the minus in here can be switched. I'm not sure why they put the negative or the minus first all the time, but you can definitely put a plus sign there. Okay, and then again, you can check your answer by doing multiplication. All right, here's another one. 4x cubed plus 16x squared plus 16x. Couple of dead giveaways, 4 and 16. We know that they have a GCF of 4. Also, our first term usually is an even number. So this x cubed, it's not an even exponent, so there's an x in each one of these. So our GCF is 4x. Okay, so we can take a 4x out of this equation, and when we divide each of these 3 terms by 4x, we're left with x squared plus 4x plus 4. We can look and see if this is a perfect square trinomial, and it ends up being, yes, it is a perfect square trinomial. It follows this pattern. Okay, and see how it saves time? Instead of having to do flowy guess and check, you can just go right to your answer. So my 4x drops down, and this factors into our perfect square formula of the quantity of x plus 2 squared. Again, you can check your work. All right, here we go. Again, these 2's are jumping out at me. The fact that there's a y here and a y here is jumping out at me. So I have a GCF of 2y. So I am going to factor out a 2y. That makes everything so pretty. Look what happens. When you divide this by 2y, you're left with just x squared. And when you divide this by 2y, you're left with y squared. I know that this is a difference of 2 squares. This right here should not say perfect square trinomial. This should say difference of 2 squares. I apologize about that. So when we go ahead and factor this difference of 2 squares, we get 2y, which is just our drop-down GCF, times x plus y times x minus y. Difference of 2 squares. And again, you can check your work by multiplying. All right, now, here we go. Factor each polynomial completely. 9x squared plus 3x minus 2. This does not have a GCF. Okay, so you skip down then to step 2. Does this look like a perfect square trinomial? It does not. And the reason it doesn't is because this 2 over here is not a perfect square. So we have to resort to using guess and check. Okay, so when you do guess and check, you just kind of have to play around with those numbers. And this is kind of like the flow chart. If you want to write all that out, you can, or you can just start plugging numbers in and see what works. And the one that works, whoops, is 3x minus 1 times 3x plus 2. Okay, so in here you would say 3x minus 1 times 3x plus 2. If you're not sure how we got that, 3x times 3x is 9x squared, so that's my first term. Negative 1 times 2 is negative 2. That's my last term. And then my middle terms, we have negative 3x, and we have 6x, which when you combine those, you end up with 3x. Okay, so that's how we got that. That's your guess and check factoring from a couple sections ago. Okay, factor each polynomial completely. Yet again, this jumps out at me. 12b cubed plus 48b squared plus 48b. 12 goes into 12, 48, and 48, right? And then there's a b in each one of these. So our GCF is going to be 12b. We have to look and see if this is a perfect square trinomial. And it is. This is actually a carbon copy of a problem a couple problems ago. And we end up with 12b times b plus 2 times b plus 2. I'm not sure why they do it this way, because you can simply say b plus 2 squared because it's a perfect square trinomial. Okay, so this whole, watch my cursor, this whole section right here, if you know your perfect square trinomial, you can skip from here down to that last step. Okay. This is a good one. I love this one. This one's interesting. There is a GCF here. Okay, you have x to the 4th minus x squared. And you can factor out an x squared. When you're left with what's left over, you have x squared minus 1. This is still a difference of two squares. This is a perfect square, and this is a perfect square. Okay, so then you have an answer of x squared times x plus 1 times x minus 1. So you could jump right to doing a difference of two squares here, but this method is actually better. You always want to factor out the GCF first. This is just a case of flowy again. There's no GCF. 3, 7, and 4 do not have a common factor bigger than 1. So you'd have to skip down to guess and check. And this is the same idea. I'm going to skip this one. I'm trying to see if there's one where we have multiple steps. Sometimes when you factor stuff, you have to factor it again. And I'm looking for one of those. I thought I had one on the slide. Okay, now this one I want to point out to you. You have 2x to the 4th plus 18. So right away I see a GCF of 2. I'm going to take that 2 and factor that out. And I'm left with x to the 4th plus 9. Do not get tripped up here. This cannot be factored any further because this is a plus sign. All right? We need to have a minus sign there if we want to do a difference of two squares. Okay, so you completely stop right there at 2 times x to the 4th plus 9. Okay, last thing I'm going to show you. This is on page 500, so I don't expect you to write this down. Just write down page 500 in your notes so you know where to look. This is, again, a nice flow chart of how to do all the factoring. Normally, if we were in the classroom, I would have printed this out for you and had you put it in your binder. So if you do have a printer and you want to try and print it out, you can. If not, it's in page, it's on page 500. Okay, your homework is page 501, 25 to 41 odd. Make sure you're writing down the work on a piece of paper, then submitting with the proper format into Google Forms. If you have any questions, please do not hesitate to ask. Have a good one.